In the second part of this video on inheritance and polymorphism, we will explain what it means to override a method and illustrate this concept with a modification of the student class hierarchy that we introduced in Part 1. Before we introduce overriding, we begin with a related concept which involves the explicit use of constructors in the classes of an inheritance hierarchy. A new reserved word is required in the constructors of subclasses that call the constructor of the superclass. This same reserved word is needed in overriding methods that call the methods that they override. The reserved word is super. It refers to the superclass much like this refers to the current class. The constructor of a subclass always calls the constructor of its superclass, whether we include an explicit call or not. The default constructor of the superclass is automatically called if no explicit call is made. If an explicit call is included, the constructor of the superclass is called using super as though it were a method name, much like this is used to call another constructor in the same class. In this case, the call to a constructor of the superclass must be the first statement. Next, we consider overriding methods. We say that a method is being overridden when the subclass contains a method of the same signature as the one in the superclass. Recall that a method's signature consists of the method name and the parameters and their types. So methods with the same signature have the same parameters in the same order. It is often useful to override methods that would otherwise have been inherited. Sometimes the overriding method completely replaces the method it overrides, and other times it just needs to refine its behavior. When an overriding method is refining the behavior of the method it is overriding, it usually needs to call that method. The toString method is one of the most frequently overridden methods. When included in a class without an explicit extends clause, it is typically replacing the version of the method that it would have otherwise inherited. Now, how a method defined in a superclass is called from a subclass depends upon whether it is overridden. Because methods in the superclass are inherited, they can be called as though they were defined in the subclass unless they are overridden. When methods are overridden, the overridden method in the superclass is shadowed in the subclass. To call the overriding method from a method in the subclass, the super reference is used to resolve the ambiguity. The time when this need most often arises is when an overriding method is refining the behavior of the method it is overriding, and so the overriding method needs to call the method it overrides. In that case, the call to the overridden method must be prepended with super. Let's examine the revised version of the student class. Notice that we have added two new instance variables to the superclass, name and major. Because there is no reasonable default values for these variables, we have added a constructor to initialize these variables with the values supplied as parameters. Let's scroll down to the remaining methods. The other method that we have added is the toString method to enable us to display student objects. Notice that we have included the annotation override. Because this is a superclass, you may wonder what method is being overridden. In this case, it is the toString method that would otherwise have been inherited from the object class. Although including the annotation is optional, it is a good practice because it enables the compiler to check that there is a method with the exact same signature that would have otherwise been inherited. A word about annotations. Annotations, which begin with the @ character, were added in version 5 of Java instead of adding new reserved words. Adding reserved words to an existing language is undesirable because it breaks upward compatibility, because it is always possible, for example, that those words have been used in existing programs as names of variables. We have made only one addition to the undergraduate class, which was to include a constructor. Notice that the only thing the constructor does is call the constructor of the superclass, supplying it with the values of name and major, so that these instance variables can be initialized. Initializing them in this constructor would not be possible because they are declared as private in the superclass. But even if they were accessible, initializing them here would be a poor practice because it would mean duplicating code, which is always something we should strive to avoid. Now let's examine the graduate subclass. In addition to adding a constructor like we did in the undergraduate class, we also added another instance variable, undergraduate major. Recall that subclasses can extend their superclass by adding new instance variables as well as constants and methods. Notice that the constructor for this class accepts 3 parameters, and that the first 2 are passed to the superconstructor, but the third one is initialized in this method. Observe also that the call to the superconstructor is the first statement of the method, as it must be. Let's scroll down to the last method in the class. Because we added an instance variable, it is a good idea to again override the toString method. In this case, we will be refining the behavior rather than replacing it, which is what the toString method in the student class did. Consequently, we first call the toString method of the student class by prepending the call with super. We then concatenate onto the end of the string that is returned the value of the undergraduate major instance variable. Because the instance variables in the superclass are private, we couldn't directly access them, and as we mentioned earlier, even if we could, doing so would duplicate code. Finally, we considered the class needed to create a runnable program, the toStudents class. We have made 2 changes to this class. Rather than calling the default constructors, we are now calling the constructors that we have written. In addition, in both of the output statements, we are also implicitly calling the toString method, so the contents of each object will be displayed. So now let's run this new version. Notice that the name and major were displayed for the undergraduate student object by the call to the toString method that was inherited from student. But for the graduate student object, the values of all 3 instance variables were displayed by the overridden toString method defined in the graduate class, which in turn called the toString method of student.